Lately, aren't the tech bros using the words priors and likelihoods a lot? What are they talking about? Hello, my name is Dushyant Goyal, and welcome to the second episode of Learn NLP with me. Good day. Today, we're tackling a fundamental concept in NLP, the naive Bayes algorithm. To figure it out, let's stick with our practical example, sorting the sentiment of news articles into the classes positive, negative, and neutral. So, what's our goal? When a new document arrives, we want to figure out with what probability it belongs to each class. Essentially, we want to know, is this news positive, negative, or is it neutral? So, before talking about how we do this for a document, let's just look at a particular word. Let's take an example. Suppose we want to know about the word strong. We have a set of news articles labeled positive, another set labeled negative, another set labeled neutral. We count the number of times the word strong occurs in each of these sets of documents, and then we divide it by the total word count for each class. Since we expect intuitively to encounter the word strong more in documents which are labeled positive, the ratio of strong to total words in positive document would be higher than for negative or neutral documents. We do this for other words in the document as well. The set of all the words in the document is called vocabulary. This way, we are able to understand that for each document given a class, what is the ratio of a particular word to all the words in that class, and with this we are able to get a measure of how likely are we to encounter that word in a particular class. Okay, so I have used the word count for this example, but it need not be the word count. Remember, in the previous episode, we talked about two text vectorization techniques. We talked about bag of words and we talked about TF-IDF. The word count is something like the bag of words, but we could also replace it by its inverse document frequency. Essentially, it gives us the same result. The it, it tells us how much more likely are we to encounter a word in a particular class of documents as compared to the other classes. Another point to note is that there is subtle difference between how I'm using the term word here. Before we calculate the word count or the term frequency, we process the document a little. What we do is we remove the very common words like preposition and conjunctions and the is are, and we also remove the conjugation and tense from the verbs, so that the words run, running, and ran are all considered the same. After doing all this, in a lot of machine learning text, you will find that they use the term frequency a feature instead of the word. So far, so good. If we have kind of understood how likely we are to encounter each feature or word in a given class. That's just the count or frequency of that particular word by the total of that class. Now, how do we build from this ratio for a particular word to a particular document? We come to the naive part of naive Bayes. We naively assume that all these different words are independent of each other. That is, the presence or absence of a word has no influence on the presence or absence of another word. Of course, this sounds like a bad assumption. For example, if you find the word vanilla in an article, aren't you expecting to see chocolate nearby? Real language isn't truly independent. Words often appear together for reasons. But surprisingly, this independence assumption that words don't influence each other works surprisingly well in practice. You'll have to take my word for it, even though if it feels counterintuitive. If these words occur independently of each other, then the probability given a class C of encountering two of the words chocolate and vanilla would just be the product of individual probabilities. Think about it. If we're flipping a coin and we get two tails, what is the probability of this? Is it just not the probability of is it just not the product of probability of getting the tail on each of the coin flips? Similarly, if the words do not influence each other, then the probability of getting of encountering a particular word in a class can just be multiplied by the probability of encountering another word, and so on for each word in the document. A document is nothing but a collection of all individual words, and thus the likelihood of seeing a document given a particular class is nothing but the product of individual likelihoods of word in that document for that particular class. This is the naive part of the naive Bayes. So far, so good. Let's recap. Up to this point, we have figured out that given a specific class, we can get a measure of how likely we are to see a particular document, or more precisely, a particular set of features. However, wasn't our goal to do just the reverse? What we really want to know is when we receive a new, unseen document, how likely is it to belong to each possible class? This is where the Bayes part of the naive Bayes theorems come in. So, the Bayes theorem tells us that for two events A and B, the probability of an event A given B is equal to the probability of B given A multiplied by probability of A divided by probability of B. What does this even mean? Well, A is called the prior, B is called the evidence, and the probability of B given A is called the likelihood. In this particular case, in the case that we're considering, the evidence is simply the chance of encountering this particular document among all possible documents. So, P of D is the probability of encountering the document among all possible documents that can be, and for documents of similar size, this is about constant. So we can ignore this term safely. Okay. We've removed one variable. So far, so good. What about the prior probability of C? Well, the prior represents the probability of each of the class. That is, how likely is it that we will see a document from each category before we look at the contents of the document. So, for example, we know how pessimistic news channels are. Suppose we have 10 different news articles. Even before we look at the document, we know a priori that it's more likely that we will encounter a negative news article. So that is what P of C or the prior means. And what about the likelihood? Probability of the document given a class. We've already discussed it. It's nothing but the probability of the various features or the words in that particular document multiplied together. Thus, the steps we need to take to calculate the probability of an unseen document being in one of the three classes positive, negative, or neutral are: number one, we convert the document into a feature set. In the last episode, we encountered two techniques to do this: bag of words and TF-IDF. Then, for each word or feature, we calculate the likelihood of the word belonging to every class. This is nothing but the ratio of the importance, frequency, or count of that word divided by the total word count or frequency count. And then we use the naive assumption to decompose a document into its set of words and features and use the Bayes theorem to calculate the probability of this unseen document based on the prior and the likelihood. Whew. So, congratulations. Now, when you overhear these tech bros talking about priors and likelihoods, you know they're not talking about something deep. It's something you understand yourself. Now, let's look at a practical example. In the three box given on the web app, you have three custom headlines: one negative, one positive, one neutral. These are vectorized using bag of word techniques, and because each class has a single document, the prior for each class is 1 by 3 over here. So we have the prior and we want to calculate the likelihood to move on to the next step. So let's check this by taking a word from the vocabulary. Okay. So as you can see, the word searched given a class positive, we have the likelihood for the word searched for neutral and for the negative class. This is done based on the naive Bayes formula that we have learned today. Why not try this out for yourself with custom headlines? You can go to this web app and put any headline that you want, and you can test this out on different words. For example, fell, right? It's more likely. So, given a negative class, we are more likely to encounter this word. Experiment for yourself. The best way to learn is by doing. Hope you enjoyed this chapter. Until next time, thank you.